Hello everyone. Today we're going to be talking about compound inequalities. So this is something different than last year you did in pre-algebra. I'm pretty sure you did 1 and 2 step inequalities as well as graphing them, and then you might have done the multi-step inequalities. Now we're going to add in compound inequalities. So compound inequalities is when you have two inequalities combined by the word and or the word or. So you're looking for the word and or. If you see the word and or, if it is written with a number is less than a variable, which is less than a number, then you can assume that it's and because it's combined. You know it's an or statement because it has the word or. All or statements will have the word or. So if we're looking here at example number 1, we have an and statement. -8 is less than x, which is less than or equal to 4. So if we break it down into two statements, then we see the word and. So whenever you have and statements, you really combine them into one, hence the compound inequality, whereas or, they stay as two separate inequalities but make a statement true. So here we have, this is actually saying in the pink, x is greater than -8. Because remember, when you are working with this, you have to read with the variable going left to right. So we actually flip it. We make a mirror image of what we have already, and it flips over. So it says x is greater than or equal to greater than -8, or it is less than or equal to 4. So if we know -8, we're going to put an open circle because it has a less than sign. And then technically, we would shade it all the way going this way. Okay. Then we have the second part of the and statement, and it says that x is less than or equal to 4. So here we have the less than equal to, and it would be pointing all the way this direction. So technically, when we end up graphing this, what we do is we only graph the part that has the overlap. So I'm going to do that again. And so where the actual overlap is just here in the center. What this compound inequality is saying is that it has to be a number between -8 and +4. It can be equal to +4, but it has to be greater than -8. And so in between there is the true statement. Nothing after to the left of -8 or anything after 4 to the right is true. It's true for the pink, it's true for the green, but it's not true for both. So that is where the overlap happens. When we look down here at this or statement, it says x is less than or equal to 0 or y is greater than or equal to 2. So it says less than equal to, and since it is an or statement, or statements do not end up overlapping. So that is why we have something like this. Notice that an and statement overlaps in the middle because it's between this and that, whereas an or statement is saying this or that. It can't be both. It's either or. All right, so here we're going to start some examples. So with this example here, I want you to remember that when you solve an equation, you have to solve everything by doing the same thing on both sides. With a compound inequality with the statement of and, which is example 3, you have to remember that this middle part here, whenever we subtract 1 to the right-hand side and in the middle, we also have to subtract to the left-hand side. It's almost as if we have two separate inequalities here, okay, which we do. They're combined as one. So -3 minus -1 is going to give us -4, less than -2x, which is less than or equal to 8. Then what we need to remember is that we are going to divide everything by -2. And so when that happens, we get +2 is greater than x, which is greater than or equal to -4. So our actual statement reads like this. Now, whenever you have an and statement, you actually need to remember that it needs to go smallest to largest. So what needs to happen is that we always need to write it with the less than signs, not the greater than sign. So what I'm going to do is essentially flip this around so that now it says -4 is less than or equal to x, which is less than 2. So my smallest number comes first, and then my largest number comes second in my AND statement. And then I'm going to graph it. Remember, the reason I had to flip my signs from less than signs to greater than was because I divided by -2. So then I had to end up basically reversing it back. So here we have -5, -4, -3, -2, -1, 0, 1, 2, 3, and 4. All right, so here I'm going to put in open or a closed circle over -4. And then I'm going to put an open circle over 2. And then I'm going to shade here in the middle. I do not shade anything before the -4 or anything after the 2. I only shade in the middle because it's this and that. All right, so now we're going to solve an OR statement and graph it. So if we look at this one says 3y minus 5 is less than -8, or 2y minus 1 is greater than 5. So what I'm going to do is work on the left-hand side here first. I'm going to add 5 to both sides, and then I get 3y is less than -3, divide by 3, and I get y is less than -1, or over here I'll have +1 to both sides, and I'll have 2y is greater than 6, divide by 2. All right. So anytime that you have an OR statement, what should happen is that they should be pointing in opposite directions. So your negative number or smaller number should be pointing to the left, and your bigger number, typically positive, should be pointing to the right. All right, so we have -1 is y is less than -1, so we shade this way. And then y is greater than 3. So notice with our OR statement, they point in opposite directions.